I'm Jessica, and today I'm going to be showing how to code code the field lines of an electric dipole in Python. So first, if we start off at the top here, we're going to just do our imports. Pretty standard. We've got numerical Python, matplotlib to plot our graphs and everything, and then circle we're going to use when we plot our dipole. So our dipole, we're actually going to display the field lines using two separate point charges, a positive and a negative charge. And the circle, we're going to use the circle function just to show those point charges and clean it up a bit. So first we need to define our function for the electric field and our variables we're going to put in it. So we're going to have Q and Q1, and then X naught and Y naught, which is going to be the position of one of the point charges, X and Y, which is going to be the position of our, first we're actually going to be coding a electric field vector, so this is going to be the position of our vector and then the position of our other charge. So it's going to, this first part, we're just going to code the electric field vector due to these two charges. So yeah, it's going to be the vector at x, y, and it's going to be due to charges q and q1 at positions x naught, y naught, and x1, y1. So right here, this is just going to be the distances from our vector to the position at y naught, and then, or the point charge at the position x naught, y naught, and then same over here from our vector to the point charge at x1, y1. And then here we just have our denominator and our numerator broken up in our equation. Our different charges, our distances for each of these, and then our epsilon naught for our electric field equation. And then right now we have EX and EY, and then EX1 and EY1, and we're going to use all this to return EX plus EX1 and then EY plus EY1, which we're then in our third cell right here going to redefine as EX and EY, which are going to be our our vector coordinates for our electric field vector. So yeah, after we code this, we can see we're calling our vector for our electric field vector, or calling our function for the electric field vector. And we've got our charges, our positive charge and our negative charge, as well as the position of the first one, the second charge, and then the vector. Sorry, that order is a bit confusing, but the vector position is in the middle. And it doesn't really matter where you put these. I just messed around with it till I got a position that looked good. So yeah, and then we can also print our vector values with the print function, and then you can see this is our two vector values for EX and EY. And then we can plot our electric field vector. So, and we're going to use the quiver function to plot this. And we're plotting it at 0.01 and 0.01, and then EX, EY. And there's our electric field vector due to those 2 point charges. And then you can go further with this and you can make an electric field map that actually contains our 2 charges, which is really cool. So what you're going to do is you can just, this is going to be the number of points in the x and y direction on our graph. I'll show you this. So yeah, these are going to be our these are going to be our point charges, and you can see this is our positive charge. We've got our vector lines pointing out, and then our negative charge, the vectors are going to be pointing in. So pretty cool stuff. And so yeah, that this 100, this is just the number of points in the x and y direction, so the points in the x and y directions. And then the rest of this is just going to be formatting the graph in the x and y direction. So the graph's going to go from -2 to 2 in each direction with this many points that we defined up here. And then by using the mesh grid function, we can add the grid to it. And this will also be important when we call our function again and turn these values into arrays. So yeah, so mesh grid, and we get our x and y, and that's adding this mesh grid right here behind our 2 points. And then in our if we move to the next cell, we can call our electric field function again, and for that position, rather than the whatever it was before with little x and little y, we're now using our big X and Y that we got from our mesh grid function, and we're turning big EX and big EX and big EY into our electric field vector arrays, which are then going to be used to show our electric field lines. So we have our vector array, or excuse me, not our electric field. Yeah, our electric field lines for this. So once we do that, then we can plot those. Plot big X, big Y, and then EX, EY, and scale it to get our electric field vectors for each of the point charges. Now we can actually visualize our electric field lines by using the stream plot function, which is going to approximate the electric field lines, and this is going to look really cool. So we're going to name our figure dipole plot, and then right here we'll use our stream plot function. So dipole plot dot stream plot, and plot x, y, ex, ey again. So the same as this, same coordinates we plotted for this, but we're using the stream plot function rather than the quiver function. And then right here we're just cleaning it up a bit, picking the color for it. So then move on, we can use our circle function like we mentioned before to show our negative and positive charges, and we can color the negative blue and the positive red. And then we can label our graph and call the x label just xm, label the y-axis, and then we can set a title and we can call it the electric field lines in a dipole. And this is what it'll look like, which I think is pretty cool. So here's what our circle function did. We've got our positive and negative charges, and you can see those electric field lines are going from the positive to the negative, and then from the negative to the positive, which is pretty cool. Or from the positive to the negative, and the negative towards the negative. So yeah, pretty cool. Nice visual, I think, and yeah, pretty easy. Biggest thing is the stream plot function to approximate those field lines, and then just defining your function up top. And yeah, I think that is all I got. Thank you.